Good day, Batang Mandunong. This is Teacher Bernadette D. Lumibaw from Eulogio Rodriguez Integrated School. For today's lesson, I will discuss with you the graph of systems of linear equations in two variables. Here are our objectives. Categorize when a given system of linear equations has graphs that are parallel, intersecting, and coinciding. Identify the different kinds of systems of linear equations. But first, let's have a quick review about linear equation in two variables. A linear equation is an equation in two variables that can be written in two forms: the standard form and the slope-intercept form. The standard form is written as ax plus by equals c, where a, b, and c are real numbers and a cannot be 0. For example, 12x minus 4y equals 8. On the other hand, slope-intercept form is written as y equals mx plus b, where m is the slope, m is not equal to 0, and b is the y-intercept. For example, y equals 3x minus 2. In this case, the slope is 3 and the y-intercept is negative 2. What is a system of linear equation in two variables? It is defined as a set of two or more linear equations with the same variables. For example, the system of the equations x plus y equals 5 and x minus y equals 1. Another, the system of the equations y equals 2x plus 5 and y equals 2x minus 1. There are also three kinds of systems of linear equations. These are the consistent and independent system, the consistent and independent system, and lastly, the inconsistent system. Given the system of linear equations, you can determine whether the graphs intersect, coincide, and parallel. You can also identify what kind of system is given. To do this, here are the steps that you can follow. Step 1. Transform each equation into the slope-intercept form y equals mx plus b and identify the slope m and the y-intercept b. Step 2. Compare the slopes and the y-intercepts of each equation. Step 3. Identify the kind of system and its graph. To better understand the lesson, let's start with our examples. Identify the kind of the following systems of linear equations and determine whether the graphs intersect, coincide, or parallel. Number 1, the system of the equations y equals 2x plus 5 and y equals negative 2x minus 1. For this example, both equations are written in slope-intercept form, which means we can easily identify the value of the slopes and the value of the y-intercepts. Let's have the first equation. Y equals 2x plus 5. What's the slope? That's equal to 2. And the y-intercept is equal to 5. Second equation, y equals negative 2x minus 1. What is the slope? It's negative 2. Y-intercept equals negative 1. Let's proceed to step 2. Compare the slopes, 2 and negative 2. Okay, yes, they are unequal. Compare the y-intercepts 5 and negative 1. They are also unequal. Since the slopes and the y-intercepts are both unequal, we can say that the given system of linear equations is consistent and independent. This means that the lines will intersect and will have one solution. Second example, the system of the equations y equals 4x plus 6 and y equals 4x plus 10. Again, for this example, both equations are written in slope-intercept form. So let's identify now the slope and the y-intercept of each equation. Y equals 4x plus 6. The slope is 4 and the y-intercept is 6. Next equation, y equals 4x plus 10. The slope is 4 and the y-intercept is 10. Now let's compare slope 1 and slope 2. 4 and 4. Are they equal? They are equal. Compare the y-intercepts 6 and 10. Are they equal? They are unequal. Since the slopes are equal, but the y-intercepts are unequal, this means that the system is inconsistent. The lines are parallel and will have no solution. For our third example, we have the system of the equations x plus y equals 4 and 2x plus 2y equals 8. Observe that both equations are written in standard form. That means we have to rewrite or transform each equation into slope-intercept form. Let's begin with x plus y equals 4. Transforming this to slope-intercept form, we get y equals negative x plus 4. The slope is negative 1 and the y-intercept is 4. For the equation 2x plus 2y equals 8, transforming it to slope-intercept form, we get y equals negative x plus 4. The slope is negative 1 and the y-intercept is positive 4. Now, compare the slopes. Negative 1, negative 1. Are they equal? They are equal. Compare the y-intercepts, 4 and 4. Are they equal? They are equal. Since the slopes and the y-intercepts are both equal, this kind of system is consistent and dependent, meaning the lines will coincide and will have infinitely many solutions. Next example, the systems of the equations y equals 4x minus 5 and y equals 3x minus 5. The given system is written in slope-intercept form. So let's start with y equals 4x minus 5. What is the slope? Okay, 4. How about the y-intercept? Negative 5. Next equation, y equals 3x minus 5. The slope is 3 and the y-intercept is negative 5. Compare the slopes 4 and 3. They are unequal. Compare the y-intercepts negative 5 and negative 5. They are equal. So if the given systems of linear equation has unequal slopes and equal y-intercepts, then that is a consistent and independent system, which means that the lines will intersect. Moving on to our next example, the system of the equations 3x minus y equals 4 and 9x minus 3y equals 12. Observe that the given system is in standard form. So we have to transform it first to slope-intercept form. Let's begin with the first equation. 3x minus y equals 4. Transforming it to slope-intercept form, we get y equals 3x minus 4. Identify the slope and the y-intercept. So the slope is 3, y-intercept equals negative 4. Let's do the same thing to the second equation. 9x minus 3y equals 12. Transforming it to slope-intercept form, we have y equals 3x minus 4. Identifying this value of the slope and the y-intercept, we have the slope equals 3 and the y-intercept equals negative 4. Compare now the slopes, 3 and 3. So they are equal. Compare the y-intercepts, negative 4 and negative 4. They are also equal. Since the system has equal slopes and equal y-intercepts, then it is a consistent and dependent system, which means that the lines of the graph will coincide. The table below summarizes the characteristics of the three kinds of systems of linear equations. Remember that a consistent and independent system has unequal slopes and either equal or unequal y-intercepts. The graph are intersecting lines with only one solution. For the consistent and dependent system, remember that the slopes are equal and the y-intercepts are also equal. The graph have coinciding lines, which means that there are infinitely many solutions. And for the inconsistent system, remember also that the slopes are equal, but the y-intercepts are unequal. The graph has parallel lines, which means that there is no solution. Now let's have some exercises. Identify the kind and the graph of the given system of linear equations. You have 5 seconds to answer. Time's up. The correct answer is consistent and independent. The graph intersecting. Next, number 2. If your answer is consistent and independent, intersecting, then you are correct. Number 3. Inconsistent system, the graph is parallel. Number 4. Inconsistent and independent system, the graph is intersecting. Number 5. Consistent and dependent system, for the graph coinciding. That ends our discussion. Thank you for joining me today. Stay safe